Dear students, today's lecture is taken from physical chemistry. As you know, the chemistry is divided into three branches: physical chemistry, organic chemistry, and inorganic chemistry. So today I'm starting surface chemistry. This chapter will take around 1 to 2 weeks. In all these days, I will explain everything to you, and after every lecture, I will be sending you 5 to 10 questions which you have to write in a separate copy. This separate copy will be checked when we will meet in school. So please remember, you have to write properly and effectively. You should not skip the written work because, as you know, you are in +2 now. So all the things which you are going to do throughout the year will respond to your CCE, that is your assessment. So the assessment which we are going to send to board will depend upon your written work also. So make separate copy for each subject, whether it is physics, whether it is chemistry, whether it is biology, or it's math. Please don't run away from hard work. So now coming back to surface chemistry. To understand surface chemistry, we have to go through two main phenomenons. The first one is absorption. We all know absorption. For example, if you take a cotton ball, you put this cotton ball into the water. After some time, you will find the water has moved inside the cotton ball. This is what absorption is. Absorption occurs over the surface as well as it goes inside the bulk. Now let's study adsorption. In case of adsorption, to understand it, you have to take a cotton ball, you have to apply some silica gel over it. After applying silica gel, you put this cotton ball into the water. After some time, what you will notice? You will notice that water is adhering or sticking only to the surface. It has not gone inside. This is what adsorption is. Adsorption is a surface phenomenon. It occurs only on the surface. It never goes inside the bulk. The substance which adsorb or on which surface the adsorption occur is known as adsorbent. As you can see from the board, I have marked adsorbent. Adsorbent is a substance on which surface the adsorption takes place. On the other hand, let's see, there is one more word written in adsorption, that is adsorbate. Adsorbate is a substance which get deposited over the surface of the adsorbent. So I hope I have made myself clear. In case of absorption, it takes place throughout the body of the bulk. On the other hand, in case of adsorption, it takes place only upon the surface. So what we are going to do today? Today I will do the introduction, in which I will tell you all the necessary things before going to question answers and further. The first introduction is adsorption. Adsorption is a surface phenomenon. Okay, so it occurs only on the surface, and always remember, it can happen anywhere. It can happen on solid surface, it can happen on liquid surface, but always remember, it will stick to the surface only. Now let's study what is adsorbent. Adsorbent is a substance on the surface of which adsorption takes place. Adsorbent is the substance on which surface the adsorption takes place. This is the first introduction about adsorption and adsorbent. Now let's consider adsorbate. A substance which is adsorbed on the surface of another substance is called adsorbate. A substance which is adsorbed on the surface of another substance is called adsorbate. Now, next term is desorption. Students, what is desorption? Desorption is opposite of adsorption. Suppose Adsorption has occurred on a surface. You just have to increase the temperature. When you increase the temperature, what will happen? The substance which was adsorbed on the surface, it will start leaving the adsorbent. It will start leaving the surface. Why it happens? It happens so because as we increase the temperature, the bonds, whether it is a chemical bond or what we can say simple physical bond between adsorbent and adsorbent, it starts breaking. When the bond breaks, the adsorbate leave the surface of adsorption or adsorbent. So what is the desorption? It is opposite of adsorption. In adsorption surface phenomenon, there is increase in concentration of adsorbate over adsorbent, but in desorption there is decrease in concentration of adsorbate on adsorbent. So make it clear, the opposite of adsorption is desorption. Now adsorption is divided into two main types. Number one, physical adsorption. Number two, chemical adsorption. As name suggests, in case of physical adsorption, there are only weak van der Waals forces, very weak forces existing between adsorbent and adsorbate. So we can say physical adsorption is non-specific. Non-specific means it can occur on any surface. It can occur on any surface. On the other hand, if we consider chemical adsorption, it is a specific adsorption. In case of chemical adsorption, as name suggests, there is a formation of chemical bonds. Chemical bonds are formed between adsorbate and adsorbent. These bonds are difficult to break. We can say chemical adsorption is more stronger as compared to physical adsorption. So now I will tell you point wise the difference between physical and chemical adsorption. Number one difference, physical adsorption is non-specific. Chemical adsorption is very specific. Number two, physical adsorption is weak. Chemical adsorption is strong. Number three, in case of physical adsorption, there is a formation of physical bond, that is van der Waals forces, which are very weak. In chemical adsorption, there is the formation of chemical bonds between adsorbent and adsorbent, adsorbent and adsorbate, and hence chemical adsorption is very strong. Number four, physical adsorption takes place in multiple layers. In other words, we can say there can be formation of more than one layer over the surface of adsorbent. On the other hand, in case of chemical adsorption, it is always monolayer. Monolayer means only one layer will be formed. Why is it so? Because once the layer is formed over the adsorbent, there will be the formation of chemical bond. So fourth point is very important, multiple layers in adsorption, and that is physical adsorption, and single layer in chemical adsorption. I hope I am making all the points clear. Please, if you are unable to go through the lecture, if you are not getting, I suggest you listen to this lecture again and again, and definitely you will start getting it. Now next definition we have, what are the factors which affect adsorption? The factor which affects adsorption are as follows. Number one, nature of the adsorbate and nature of the adsorbent. If there is a strong attraction between adsorbate as well as adsorbent, the adsorption rate will be very high. Let us consider if we have what we can say elements or molecules from group 17. As all you know that group 17 is always run for one electron, because after gaining one electron, its electronic configuration becomes equal to noble gases. So it always seeks electron desperately. So if we take any element from group 17, the adsorption rate will be very high. Now let's consider another case. If we take noble gases, the adsorption rate will be very low. Why adsorption and absorption takes place? To gain and lose electron. But as you know, noble gases don't require any electron. Their electronic configuration is completely filled. They don't require electron. So they will not participate in adsorption or absorption. That is why they are called noble gases, because they don't react at all. So nature of adsorbent and adsorbate also play an important role, is a vital role we can say. If the adsorbent and adsorbate are highly reactive, adsorption will be very high. If the adsorbent and adsorbate are non-reactive, the adsorption will be negligible or very low. This is the first factor for adsorption. That is the nature of adsorbate and adsorbent. Second factor is specific area of adsorption. Now understand very carefully. You take a piece of log. And you try to burn it. You will find it difficult to catch fire. But if the same piece of log is converted into powder form, once it is converted into powder form, you will see that it will catch fire very fast. Why it is happening? The moment you are changing the log of piece into a wooden powder, you are increasing the surface area. Yes, that is the second factor of adsorption. If you increase the surface area, the adsorption rate will be very high, because more surface area, more adsorption. So always remember, second factor is rate of adsorption depends upon the surface area. In other words, one more thing, adsorption is directly proportional to the surface area. More the surface area, more will be adsorption. Now third point is activation of adsorbent. You can really, if the adsorbent is not activated, it is not responding to adsorption, you can increase rate of adsorption. How you can do so? Very simple. You just have to rub the adsorbent surface with some kind of rough paper. If we increase the surface area by rubbing the rough paper over the adsorbent, we are again creating factors which will increase adsorption rate. So this is what we call activated absorption. Now to make you understand activated absorption more clearly, let's talk about charcoal powder. You take a piece of wood, put it into the test tube, close the test tube and start burning this piece of wood. What we are doing? We are burning the piece of wood in the absence of air. Soon, what will happen to the piece of wood? It will start burning. It will change into ashes. These ashes, which are produced in the absence of air, is known as charcoal. Now, this is also called activated charcoal, because when you try to carry out adsorption on this activated charcoal, the rate of adsorption will be very high. This is what we can say. The third point is activation of adsorption and activation of adsorbent. That is, you can increase the power of adsorbent by changing into powder form, by changing into charcoal. If you are using wood will be absorbing less as compared to its burned form. The burned form of wood is called charcoal. Now we have come to fourth point, that is the fourth factor, pressure of the gas. Pressure of the gas. If you will increase the pressure during adsorption, definitely the rate of adsorption will increase. Rate of adsorption is directly proportional to pressure of the gas. If the pressure is more, adsorption will be more. Last point. That is the fifth point. The fifth point is temperature. As you know, whenever you increase temperature, what you usually do? You increase kinetic energy. You know the difference between kinetic energy and potential energy. In lower classes, you have learned that potential energy is the energy possessed by the body when it is at rest. And kinetic energy is the energy possessed by the body when it is in motion. The potential energy can be represented by the formula, let's talk about physics, mgh. So, always remember, if we consider potential energy, it is mgh. And if we consider kinetic energy is the energy possessed by the body when it is in motion. So my dear students, when you increase the temperature, first of all, adsorption will increase. If it is a chemical adsorption, it will increase with increase in temperature. Why? As you know, in case of chemical adsorption, we require formation of chemical bonds. Chemical bonds cannot form without the use of energy. So they require energy for its formation. So when you increase the temperature, the kinetic energy increases, the energy of the system increases, and chemical bond starts forming. So in the starting, in case of chemical adsorption, with increase in temperature, the adsorption will be very fast. The adsorption rate will rise. The adsorption rate will show exponential graph. You know what exponential graph means. But as you further increase the temperature, if you go on increasing the temperature, what will happen now? The chemical bonds which are made, they will start breaking because the energy is exceeding. It is going to that limit that the bonds which are formed, they will start breaking up again. So as the temperature increases, first of all, instantly the rate of adsorption will increase. But if we further increase the temperature, the rate of adsorption will decrease. Why so? Because when we increase the temperature, initially the chemical bonds formation takes place, but with furthermore increase in temperature, the chemical bond formation will stop and chemical bond breaking starts with a very high temperature. Hence, the rate of chemical adsorption decreases. Now, what will happen if we increase the temperature with respect to physical adsorption? As I have already told you, physical adsorption takes place by the formation of van der Waals forces, simple bonds, London forces. So, the moment you start increasing the temperature, the physical adsorption starts decreasing. The graph starts dropping. Why that so? Because there are no chemical bonds, there are only weak van der Waals forces of attraction, there are only weak physical bonds. The moment you increase the temperature, the kinetic energy, which is half mv square, as I already told you, potential energy is mgh, kinetic energy is half mv square. The kinetic energy will start increasing as we are increasing the temperature. What will happen instantly? Spontaneously, the bonds will start breaking. So what will happen in case of physical adsorption? We will receive a graph in which there is a continuous decrease in rate of adsorption, because the moment we increase the temperature, the bonds starts breaking. It is not like chemical adsorption. Now, coming to the conclusion, if we increase the temperature in case of chemical adsorption, the adsorption will increase first, it goes high, and then it will decrease. We can say in case of chemical adsorption, we will get a bell-shaped graph. If we plot a graph between temperature and rate of adsorption, we are going to get a bell-shaped graph. But in case of physical adsorption, we will get a graph in which from the starting itself the rate of adsorption will decline. It will decline as the temperature will increase. So now I hope you are clear with the factors. So I'm revising the factor. The first factor which affects surface chemistry, that is adsorption. The first factor which affects adsorption is the nature of adsorbent and adsorbate. Second factor is surface area of adsorbate and adsorbent. Third factor is activation of adsorbent. Fifth factor is pressure of the gas. Sixth factor is temperature. So, my dear students, please remember one thing. Now the time has come. We have to study. As corona outbreak is there, we don't know how long we have to linger upon. We don't know how long we have to wait at home. It doesn't mean that we are going to waste all the time. Please don't waste your time. The studies, they have taken the next level. That is, we are online every day or so, day or day after tomorrow. We will be giving you lectures on our important topics. You will be covering those topics. You will be writing all the questions and answers which we will be sending you in the group. And when the school starts, keep it in mind, we are going to check all the copies. So please, again and again, I am telling you, don't take it lightly, because the studies will be very, very fast, very, very what we can say spontaneous, because we will be having very less time to complete the syllabus, and your paper will also start very soon. That is the board exam. It will start very soon. So don't make it tough for you. Start studying from today itself, as we are studying from week or so. Keep on doing your task, keep on doing your course, and remember, your assessment marks will be taken out or will be evaluated on the basis of your homework. So do notice and make one thing clear. No matter what, you have to complete your copies. Every day, whatever homework we are giving you, you have to complete your copies, and I will be sending you all audio visual aids like today's lecture. I will be sending you everything. So a small revision, what we did today. So started with absorption and adsorption. Absorption takes place inside as well as on the surface. Adsorption takes place on the surface only. The substance which is adsorbed on the surface is called adsorbate, and the substance on which adsorption takes place is called adsorbent. Adsorption is a surface phenomenon. Absorption is a bulk phenomenon. Please keep it in mind. And after that, we went to the desorption. Desorption is the opposite of adsorption. It is the opposite of adsorption. As adsorption increases, the desorption is the opposite of it. If we are talking about desorption, we are talking about decrease of adsorption. And I have already explained to you what is desorption. Now, then I told you about difference between physical and chemical adsorption. Physical adsorption, in which normal forces are there, whereas in chemical adsorption, strong chemical bonds are there. And even I have explained the different points, difference between physical and chemical adsorption to you. After that, I went to factors affecting rate of adsorption. So today is Easter. Happy Easter to all of you. Stay safe, stay home, don't go out, follow all the important instructions given by the government. These are for your good only. Always use sanitizer when you came back, or you can do 20-second hand wash. Always stay away from the sick people, interact less, meet less people, be non-social for few months or few days, because We have to recover as soon as possible. Best of luck. Thank you.